Hi, I want to talk to you about a map that I'm working on. The goal of this map is to make it easier to make observations of space weather at the poles. Space weather being a blanket term for variation in the sun and how it impacts the Earth. I've written this talk for a general audience with an interest in polar research, so expect some simplifications. You've probably seen an image like this, with the Earth as a bar magnet, and the field lines, like the lines that you get when you surround a magnet with iron filings, making up the magnetosphere. Of course, the magnet isn't perfectly simple, and the Earth's magnetic field shifts with time. So there's a separate magnetic coordinate system that measures this variation, and you can convert from geographic coordinates to magnetic coordinates and back again. If you have a point at one location on the Earth, and you trace along that field line to a matching point on the other end, those 2 points are geomagnetically conjugate. For a really thorough review of interhemispheric comparisons using ground magnetometers, check out Mike Hartinger's magnetosphere seminar. He talks about how conjugate magnetometer observations of the poles can be used to look at magnetic perturbation events, ultra-low frequency waves, how ground magnetometers respond to upstream pressure variations, interplanetary shocks, and solar eclipses. And that's just magnetometers. There are things we can learn from other conjugate sensors too, like all-sky cameras that can capture conjugate auroras matching up between the poles. Space weather in one hemisphere is directly connected to the other, and we can detect these matching variations on the scale of minutes. But in order to observe these relationships, we have to know where to look, and we have to place sensors appropriately at conjugate points. And that's kind of hard, because a lot of common mapping tools tend to break down near the poles. And it's additionally complicated, in our case, by the vertical scale of the Geospace system, and ionospheric observations, which have a lot to do with photoionization, are also affected by the fact that solar zenith angle is very different at the poles. This isn't usually a problem in the mid-latitudes, but at the poles it becomes a three-dimensional problem. Or rather, it becomes a three-dimensional problem we can no longer afford to treat as though it were two-dimensional. This is especially true for eclipse paths and satellites. So let's talk about maps. This is a geomagnetic conjugate map from 1987. So what these authors did was take the coordinates for the coastline of Antarctica, as well as the coordinates for their instruments, swap them into magnetic coordinates, mirror them onto the northern hemisphere, and overlay the two. And this lets you look at any point in one hemisphere and find the conjugate point in the other hemisphere, or it would if the resolution were higher. I'm working with the Polar Geospatial Center at the University of Minnesota to redraw these as larger scale reference maps for geospace scientists. The idea would be to have a map that you could look at either in the northern hemisphere to identify locations conjugate to instruments in Antarctica, or the other way around, to identify locations in Antarctica where conjugate instruments could be deployed. I'm looking to collect input from the geospace community and the Antarctic instrumentation community about how such a map could be used and what you would want to see on it. So please fill out the survey and let me know if there are any particular features, stations, or paths that you would like to see represented for your work. So to recap, geomagnetically conjugate observations are useful. They can give us a lot of information about the flow of energy in the Earth's geospace system, and they're one of the things that make the polar regions valuable as a scientific observing platform. We could use more of them, especially in coordination with research organizations in the Northern Hemisphere who are interested in space weather and who have conjugate locations overlapping with the Antarctic. Improved visualization tools, like new reference maps, can help support these types of observations and encourage new ideas that leverage this capability. Such a reference map is under development, so please fill out the survey if you are interested in using it for your research. Thanks for your time. And please email me with any questions.